Hi everybody, welcome to Geometry Notes. So in these recorded notes, one thing that you need to know before we get started with Geometry Chapter 1, Section 1 is that you have got a pause button. So feel free to stop, pause, rewind, whatever you need to do to make sure that you get these things down. I don't have anybody here to watch to see if you're keeping up or I'm going too slow. So we're going to start off with geometry, lots of terminology to start with. So we're going to start with points, lines, and planes, the most basic terminology and concepts that we're going to use throughout this chapter, this year. So technically, points, lines, and planes are undefined terms. It's hard to define them. We explain them using examples. A point is a dot on a graph or perhaps just on a board. Here is a point. We'll call it point P. So we explain it with examples. A line is a line, right? It's hard to explain. A plane is a flat surface. So we use these terms then when we define other terms as we go along. So a point is a dot, and we label it with a letter. It's symbolized, so as we go through, you're going to see, I'm going to say all these things a couple times in a couple ways. It's symbolized by a dot, and we always name it with a capital letter. Don't put a small m or a small t. It's going to be point capital M or point capital T or P or whatever letter you or I choose. The characteristics, all we can really say, it's basically just a location in space. It could be on your ceiling, it could be on my board, it could be on your desk, it could be on your paper, right? It's a location somewhere in space. A line is actually technically a series of points. And let's do this first. It's named by two of the points that are on the line, or we can use a small cursive letter. So let's draw a line. So first of all, everybody knows, what does a line have to have at the ends of it? We always put arrows, right? Because a line goes off in both directions forever. If it doesn't have arrows on both sides, it's not technically a line. We'll talk about those in future sections. And then we can do two things. We can put a whole bunch of points on here. We could call this point N and point P. We could put a point Q. Remember, all of those points on that line are capital letters. So we're going to name it using 2 points. So maybe we call it line NP. And you actually put a little tiny line above it with the arrows on each side. That tells us it's a line. Again, if it doesn't have the arrows, it might be a ray or a segment, and so we need to know that just by looking at the symbols for it. We can also call it a small cursive letter. So maybe we're going to call this, let's see how good your cursive is. I'm going to call this Q. That's a Q right there in case you can't tell. Usually that small cursive letter is by one of the arrows, by one of the ends. So I could put it up here. So we would just call it line Q. Small cursive letter symbolizes a line. 2 points with a, 2 points with a line above it symbolizes a line. You can name it either way. They're both right on a quiz or a test. And a couple reminders, make sure you put an arrow at each end. And if I had drawn those points N and P first, there's only one line that can go through them because we always know that lines are straight. And last but not least, a plane is, we'll do this middle again. It's a shaded, slanted quadrilateral. It's a flat surface, any flat surface. So if you're looking at your piece of paper, hopefully it's flat. It's a flat surface. A plane goes on in all directions forever, exactly like a line goes off in 2 directions forever, but we can't draw that. So we just draw it as a shaded, I'm not going to shade it because it gets messy, The book will always shade it. A slanted quadrilateral, a four-sided figure. On that quadrilateral, I'm going to put this over here. There's exactly one plane through any 3 points. So typically we're going to see 3 or more points on any plane. So I could put on a plane, or sorry, a point Q. Notice this point Q is different from our line Q. It's a capital letter Q, as opposed to our line is a small letter Q. Sorry for the technical difficulties. I'll put an R and I'll put an S. So we could call that plane QRS. If I put a T on that plane, we could call it plane TQS, plane TRS, plane SQT. 3 points on that plane. Notice they're kind of triangular shaped when you look at the 3 points. We could also call that by a capital cursive letter. So perhaps you want to call it, it'll usually be in the corner. Not very good at capital cursive letters, but we could call that plain M, capital cursive M. So any 3 points, we can make a plane through it, even if those 3 points are horizontal, vertical, slanted, diagonal, on the ceiling, on the wall, wherever it might be. All right, so that's our most basic undefined terms that we use in geometry and that we use to name other concepts that we're going to use. So we need to know what collinear is. If you know anything about root words, you might see that the root word for collinear is line. Co means together. So collinear are points that lie on the same line. Non-collinear is just the opposite, points that are not on the same line. So I'll ask you, I'll say something like, are points Q and P collinear? Coplanar, same idea here. Plane is the root word of that. So these are points that lie on the same plane. We could actually say lines, points or lines that lie on the same plane. So I might say, are lines L and M coplanar? And then non-coplanar is just the opposite of coplanar, points that are not on the same plane. So perhaps I've got myself a plane down here, R, there's plane R, and I would say here is point X, Y, and Z. Are points X, Y, and Z collinear? I'll put Z down here. X, Y, and Z collinear. Doesn't look like they're on the same line, right? I can't draw a line through all 3 of those points. So they would be X, Y, and Z are non-collinear. X, Y, and Z, are they coplanar? Well, X and Y are on the same plane, but Z is not. So X, Y, and Z are non-coplanar. One point that's not on that plane makes it non-coplanar. If I moved Z up here, then we'd say, oh yeah, X, Y, and Z are coplanar. I'll keep them non-coplanar just so you can see what that looks like. All right, so here's what we're talking about. Let's just talk about 1 or 2 so we can keep things moving. Use the figure to name each of the following. A line containing W. Notice that's supposed to be a capital letter, which means that that is a point. So what's a line that contains point W? There's W right there. How do you name a line with 2 capital letters or a small cursive letter? So we could name this line right here that W is on. We could name that line N. Or we can choose any 2 points on that line. So we could name that line WV. Don't forget the line symbol above it. You could actually name that VY. right? Because W is still on that line. We don't have to use the W to name it. We just know W is on that line that V and Y are also on. So a plane containing X, this is another point. So a plane that contains X, well, X is right here in the center. I would say probably the easiest name to plane to name is that large slanted shaded quadrilateral plane P. That's supposed to be cursive. The book sometimes has trouble making cursive letters look a little twirly. So, all right. So we're going to do a lot of identifying things like that. Intersection. Everybody knows intersection. A lot of people are getting into driving probably, or are driving already, or are driving illegally. I don't know. But intersection is where things cross or meet. There it is. Or touch. They intersect. Two streets intersect. A lot of times you have a stoplight or a stop sign. So where two things cross or touch. So I'm going to ask you some questions about, like, do you see two lines, L and M, in this middle example right here? Do you see two lines? Are those two lines L and M intersecting? They are, right? Where L and M intersect, what is formed? A point, and specifically point P is where those two lines intersect. This example over here is an interesting one. So do you see two planes intersecting in that example? I see a green horizontal plane A, and I see a blue, sorry if you're colorblind, vertical plane B. And those two planes are intersecting, they're crossing or touching. And it looks to me like more than a point is formed when you have those two planes intersecting. I've got this whole line right here, line R. I don't know how to make a cursive R. Line R is the line of intersection. So when two planes intersect, we've got ourselves a nice line because there's got to be a lot of points where they cross. All right, and space, I mean, the book just says I have to tell you about this. Move this up here a little bit. Space is the boundless three-dimensional set of all points. It can contain points, lines, and planes. Probably should have said that right at the beginning. So we are working in space, obviously, inner space, not outer space. But we have points, lines, and planes that can be all over the place. They can intersect. They can be collinear, coplanar. They might not intersect. But that's where our space is that we're working on. All right, and let's try to make a drawing. So number 3, we're going to draw and label a figure for the relationship. Let's do A. So it says QR, and I really should have put a line above that line, and I know it's a line because it's capital letters. Line QR intersects plane T at point S. I always start by making the largest figure. The largest figure, think point, line, or plane. Plane is the biggest thing. So let's draw ourselves a plane, and let's call it T. I don't know how your cursive T's are. So if I've got plane T, and it says line QR is going to intersect plane T, that means it's got to cross it or touch it, but it's not going to lie on top of it, right? So that means QR is going to have to go right through plane T. Think of like a pencil. If you stab it right through a piece of paper, don't try it at home. So plane Q or line QR, so I'm going to have to draw a line. I've got myself a little point there. And then we draw a dotted line where it's back there, but we can't quite see it. So I don't know how your 3D thinking skills are, but that is a line that's intersecting that plane T. Now I want to name it line QR. So Q and R are just 2 points on that line. So I'll just put a point here and call that Q. R, it does not matter where they go, if the R is higher or lower. as long as they're on that line. So that was my second biggest thing. So then the smallest thing is I've got a point S. Where does point S have to go on this diagram? Point S is where the line intersects the plane. So this point right here has to be point S. Those are often the trickiest things for people to do because you got to kind of figure out. So again, my philosophy is start with the biggest thing, make a plane if you need a plane, then go to the line and how it fits. In that example, if I said that QR is coplanar to plane T, I would have just drawn it right on top of there within the bounds of plane T and put my point Q and R. So Q and R would actually be on plane T. In this example that we drew, Q and R are not on plane T. And if it looks like Q is on plane T, scoot it up there so you can see plainly that it is not on plane T. Remember, a plane goes on in all directions. The flat surface goes on in all directions forever. So we have to draw boundaries because we have to see something. So we can put plane Q up there if that makes more sense to what it looks like. All right, last but not least, let's do 4 and 5. So we've got this figure with a lot of things happening. Number 4 says, how many planes appear in this figure? Name them. This is an interesting one because we've got planes going in all sorts of directions. I'm thinking that everybody sees the horizontal plane X, right? Plane X. So this guy, this big one right here, that's a plane. Then I've got that pyramid sitting on top of it. Do not double count the bottom of the pyramid and plane X. It's the same plane. It's resting on top of it. It doesn't count twice. So if I look at that pyramid, it looks like it's got 5 sides. They're all triangular. So I know we said we drew a plane as a quadrilateral, but keep in mind that a plane is a flat surface. So I've got 5 flat surfaces that are going up to the point of that pyramid. I've got the bottom of the pyramid that was already counted as plane X. So it looks to me like I've got 6 planes. If I were to name this plane right here, that triangular plane, remember we name planes by either a capital cursive letter or a 3 points on the plane. So we could call that one that I outlined plane DFG. This plane that's right up here in the front that I drew very poorly, we could call that plane DHG. So 3 capital letter points or a capital cursive letter. So there's 6 planes altogether. 3 points that are collinear. I'm going to erase my drawing over here so I can see a little better. Collinear means on the same what? On the same line, right? Looks to me like I've only got one set of 3 collinear points. This line over here is really nice, but it only has points L and M. L also happens to be on plane X. But if I look at this line over here, it doesn't have arrows at each end because it's a part of a figure, but we're still going to call it a line. So D, K, and J are collinear points. Notice I named those with capital letters because they are points. So watch for those kinds of things. We'll stop there for section 1.1. I know it's a lot to take in. We'll do examples in class and we'll talk things through and do some practicing of identifying. Have a good one. We'll see you next time.